Thank you, everyone. What I think Pavel missed was to say that today's sessions, both of them are somewhat connected to the proliferation of Kubernetes. So Gardner here is kind of the topic, hosting control planes. It's about Kubernetes used for Kubernetes everywhere. And the next talk, by the way, is about Kubernetes being used for everything everywhere. So there's a connection. So that's how far we've come in 10 years. Yeah, my name is Vasu, and with me I have Tim here. And I'll be talking a little bit about Gardner, but not so much in the details. You'll see. But this is, by the way, the first talk on Gardner in our own meetup, right? So I never did that before. So anyway, hosted control planes. Let's get it done with. Let's dissect the Kubernetes explains the different planes. Let's explain that quickly. So we have in the middle, this round thing is, let's say, the persistent storage like etcd, and the API server is kind of the red ring around it. And that gives you the data plane. I call this the data plane as opposed to, let's say, in the networking spaces where our data is actually structured and persisted. And in order for this data plane to work, you obviously need some in-house controllers like the service account or namespace controller just to do the housekeeping of the data plane. Okay, so you can think about this, that this is the nucleus of Kubernetes. And you will hear something more about the nucleus or the connection to the next project, KCP, in the next talk. And this is not Kubernetes fully. So what you need on top for the Kubernetes control plane, as you know it, you need all these controllers that you know, the job, deployment, and replica set, and things like that. Now that's the Kubernetes control plane. Yeah? The work actually happens in the Kubernetes work plane. That's where the hosts, the real nodes, are situated. And in order to control them, Kubernetes comes with the kubelet. And you see that the kubelet also has a digital twin object in the data plane, right? And then there's a little bit of auxiliary stuff like the kube proxy and DNS and so on. There's some more just for the for Kubernetes to work. And Kubernetes became so great because of extensibility options, the CRDs. So you can define custom resource types, and the work for these custom resource types, you need custom controllers. You run them typically in the work plane, right? So this is like the typical way how you essentially run your Kubernetes clusters. But remember, the custom controller that you put in does not need to run in the Kubernetes cluster. It can run outside on your laptop. Your developers, you develop on your laptop. So as long as the custom controller has access to the API service and has the right credentials, it can do its work anywhere. So remember that, because that is the way, or that opens up a way to actually reorganize the different control planes, or different planes. Right? So the controller gets its work from the data plane. That data plane can be a Kubernetes cluster or a nucleus, something reduced, right? But the controller does not need to run in that Kubernetes cluster. It can run on your laptop or on a different Kubernetes cluster, right? Obviously, you rather want to use a Kubernetes cluster because then you can take that controller, put it in a pod, and auto-scale it horizontally, vertically, and so on, right? And the work that the controller needs to do for you does not need to be any of these Kubernetes clusters you're seeing here, 1 and 2. It can be some other payload cluster. It can be Kubernetes, or it can be anything with an API, and that's the whole idea of crossplane. Now, why do we separate the concerns here? So the first thing is obviously security. The security boundaries are needed so that you can't have an attacker vertically cross. If everything is in one cluster, you're screwed. But the other thing is about scaling. So the idea of hosted control planes is just that. Take the complete elements of the control plane, the etcd, the API servers, all the controllers, put them in a pod, let it run on a Kubernetes cluster as a host, and then for scaling purpose, put that in, put the API in a data plane and add some nodes via a machine controller set or something. That's it. So I could now go deeper in and explain you how Gardener works, but I'm not going to do that. I'm going to explain it a little bit differently, because I'm going to ask the rhetorical question, how does it actually help me to create so Kubernetes is not the end game. You obviously want to earn money with that. Yeah. And you earn typically money with some type of a software as a service offering, right? So I'm going to ask, I now have some type of a management API that gives me Kubernetes all over the world. And my work or my challenge here is I have an application and I want to use Kubernetes to distribute it globally, right? And by the way, the guy who created the slides here is also here, Uwe. Thank you very much. I'm using them in a vanilla form, right? So, and in order to get there, I need to take you a little bit in a different route first. Let's see Kubernetes controllers in action. Most of you already know Kubernetes, but there might be some people who are new here. So let's take a look at this scenario. I have a deployment of a payload, and I want that payload to be exposed via a DNS record to my end user. So what's happening behind the scenes? So the deployment doesn't automatically create the payload. I need a pod for that. Now the pod, which describes the payload, doesn't automatically get onto the host. It actually needs a scheduler and a node object so that represents the host. And then it needs the kubelet to do the work and then establish that container as payload. But you all know that typically we don't deploy pods. And in my scenario, I started with a deployment. So obviously there's an abstraction called replica set. That only creates the pod. And then again, you need a deployment controller, which creates the replica set. So another abstraction on top, right? So this was the compute side. What about the networking side? There's a kube proxy that wants to create an internal service and service for the ingress, but it doesn't work automatically. It actually needs an endpoint, and the endpoint controller gets that out of the pod, right? And then, yeah, I'll do this quickly. You need ingress controllers. You have a load balancer with the cloud controller manager. And if you want a DNS record, you also have a couple of controllers on top. This exercise was actually done because there are 4 lessons actually out of this. The number one lesson is this architecture. It's actually called repository pattern. Yeah. Would you think, this is a rhetorical question, that a waterfall architecture council, would that council approve such an architecture? And because it's a rhetoric question, you already know the answer. It's no, in my opinion. The second thing is that I think Lukas Karlstrom called it in his bachelor thesis, control through choreography. I like to call it Adam Smith's invisible hand, because all these controllers are relatively egoistic. They only take care of their own concern. They're not, concerned with all the global system health and so on. They only take care of their own. Yeah? And still, in the overall end, if you don't have a crooked controller, but only honest participant, this system is so much more robust than any other system architecture, right? And the fourth lesson is hopefully a surprise for you. Only concentrate on these 4 things here, because there's a natural, I call it the Euler function, the Euler exponential function here, pattern, hidden in front of your eyes. And that hidden pattern is needed for your global software as a service task. Okay, so, and that leads us to the cloud native service pattern. So let's take a look at it. So obviously, we'll adapt Kubernetes design patterns. So this is a digital twin thing. So imagine your application, you want to expose that. We just put a dashboard in here as kind of the the glue code or the bridging between some type of a UI. And you would model your service with, let's say, with digital twin objects, so that the user goes to the dashboard, and the dashboard then creates service instances that kind of declaratively model the kind of service application or service instance that you want to materialize. So then you have an instance controller. That instance controller now sees there's a service instance or two objects, and then it has a payload cluster, and then it just creates the number of instances, whatever it is, in that Kubernetes cluster. Okay. All right. So now how do we organize that? I alluded to that we do the separation of concern. This is not, you can't put everything into one single cluster, not at global scale anyhow. So we will have a management cluster, a Kubernetes management cluster, where we put the instance controller and whatnot in it. We have the payload cluster, and we separate out the data plane into another controller, into another cluster. Could be a nucleus or another Kubernetes cluster, right? And now let's say your global application is really successful. There are more instances being ordered. So obviously that one single Kubernetes cluster is not enough. So what you do is you add another one, and that instance controller then has two clusters to choose from, right? And then it distributes the workload over there. So how scalable is this? So surely it works with 10. 10 clusters. Maybe it'll work with 100, but does it work with 1,000 or 10,000, depending on your workload, of course? And does it actually make sense to put the instance controller, the central control in Europe, and have the Kubernetes cluster where the payload is hosted in Australia? Does it make sense? Again, a rhetorical question, obviously not. So what do you do to get scalability? You separate out the instance controller. And the way you typically do it is that you put the business logic into a servicelet that is local to the payload cluster. And now you have a new object called the runtime that describes that payload cluster. And you can add a scheduler in there. So this means that when the service instance is requested, the scheduler actually says, this service instance should be scheduled to this runtime. After that is done, the servicelet is taking action and does the needful. So you have localized business logic, right? So there's actually some more things that you can now do, because now you have information about in that runtime object. You know how many instances are running. Is that Kubernetes cluster full? Do I need another one? So you can add a runtime manager as an additional controller, which then, if there's no more Kubernetes cluster available, or there's no Kubernetes cluster in the region where you want that payload to run, it can actually go in and order a new Kubernetes cluster using a Kubernetes as a service. Yeah. Okay. And then configure the servicelet and so on. So obviously, by now, you should have already recognized, because I pointed you directly to it, this is the kubelet pattern. This is exactly how Kubernetes solves it or does its work in a local cluster. And that's what you can do for at global scale as well. You just need different type of objects, right? And that's exactly what we do with the Gartner architecture, hosting control planes. That's it. Yeah? We call it Garden-led, and we have a Gartner autoscaler. We create our own infrastructure and so on. We have some different names in it. And if you look closely there, we actually use a Kubernetes cluster. We call it seed, to then create the Kubernetes cluster for the end user, which we call a shoot. And there we called it infrastructure as a service environment. Yeah. Okay. So that's basically it. So within SAP, we actually use the Gartner infrastructure or the Gartner service to host applications, any type of applications at global scale. And this is not all. You can actually, if you have a multi-tenant service instance or service, you can actually use the same pattern to actually add abstractions on top, right? Like if it's a multi-tenant, you can have a digital twin called a service tenant, and you have a tenant scheduler and an instance manager. I think this should be clear, right? So the conclusion is you need something like hosted control planes, like Gartner, in order to get to a software as a service objective for at global scale. Right? Yeah, I promised you the Euler function, right? So take a look at this picture again. Take a look here. We used Kubernetes for management. We used the Kubernetes infrastructure for hosting the control planes, and we use Kubernetes for end users, right? So the Euler function is the exponential e to the power of x with the natural constant 2.71 and so on. It's a peculiar function because it represents recursion, replication, and growth in nature. It has really a scientific reason. This is, I just say, this is how nature bootstraps, right? And if you take a look, why I draw this similarity or analogy, it's like at a given point x, the value of x in the function is e to the power of x. At that particular point x, the gradient or slope is actually e to the power of x. And the area underneath that curve is e to the power of x. Yeah, so this is kind of a interesting, yeah, a peculiar design that nature has. And if you say Kubernetes is the constant E that you need, then surely Gartner or hosted control planes is the function, the exponential function e to the power of x. Because, you know, in Kubernetes itself does not use Kubernetes itself to produce its computational workload, right? You could call it also closure, right? Quod ita erat demonstrandum. Okay, so, and then I often get this, yeah, even fights with why does Gartner or hosted control planes, as for that, does not use cluster API. Yeah, you can do that. Yeah, but we started very early. Yeah, and I'd like to present our way to look at it. So when you think about how we designed Gartner, right, or the outcome of Gartner is we kind of have a thinking top down. Imagine you already have a distributed system where Kubernetes is at your fingertips. Don't care where it came from. The API you would design is a little bit different. You kind of look at it more holistically. And then you kind of think about, okay, how do, now that I have a distributed system, I can do something with the control plane. I can do auto scaling. I can create my seeds for the control planes. I can do pivoting of the control planes. And then you think about the scalability factor, the localized business logic in the Gardenlet. And you start kind of with the platform thinking of homogeneity. The Gartner has extensions on different type of GCP of infrastructure like GCP, AWS, and so on. But the output is quite, yeah, is more homogeneous. And you kind of think about right from the start that your when you roll out things, that your Linux images, for example, should be everywhere where our platform is available, right? And you can do policy and so on. If you start from a bottom up, you know, everything is a machine. Your thinking is different. Yeah, you kind of say, okay, I need to bootstrap first of all, and that's where K3s, kubeadm, kind, and so on come to play. And cluster API is totally formed out of that mindset. Yeah. So, and there are cluster API providers for GKE, AKS, and so on, but kubeadm as well. But they differ. You don't get that kind of homogeneity because obviously GKE is different than kubeadm, as an example. And the platform thinking is something you have to bolt on afterwards. So in the middle, by the way, we meet. And I think Kubernetes and us, we were kind of the first ones who started with the machine set, machine deployment, and things like that, right? So we kind of do meet in the middle. But in the end, you know, what happens is that, and this is the fight, I think we, not the challenge it is, that cluster API is very attractive for individual developers because it's immediately productive on their laptop, right? And with that, they say, there are then service teams that then say, okay, we've got it running, and then we create a service around it. And what we did, hosted control planes, Gardener, and so on, is attractive for service teams. So you have to have that scalability problem first, yeah, in order to adopt Gardener. And that's, by the way, where we actually see adoption, right? So in the end, the top part, the green part, is your bootstrap function, e to the power of x, and in the below, you're, yeah, a pirate. Okay, so have Gardener or hosting control planes, has that been successful? Again, rhetorically, yes, at SAP at least, it's kind of powering many parts of the business technology platform or commercial platform. So interestingly, even our monolithic software stacks run on Gardener. They have been containerized. So ABAP Cloud has been containerized and runs on Gardener. And the project's name, by the way, is Steampunk, you know, taking the old steam engines and making something interesting out. That's their project name. We even, and the prediction of Kelsey has come true. Yeah, monolithic application will be back in style. Yeah. He did that 2020. Yeah, 2023, at least it's reality. And we even go so far, we have stateful services like our in-memory database, HANA. HANA Cloud runs on Gardener. And we also have adoption outside. I don't know if today somebody from Lidl, Schwarz Group is here, but they run Gardener as well. We also have small and medium business hosters like the Metal Stack guys. They run Gardener to run the nodes on Metal. And we have European hosters, sovereign hosters that use Gardener, startups, and that looks funny. Okay, yeah, I think there's something. Yeah, it's wondering already. CodeSphere here, I think. Tim is also here. I see him. They run Gardener, but not to expose Gardener itself. They run their software on top. And we even have China Scale here. The Titanium database, also a CNCF project, for their commercial offering, they use Gardener. All right, and with that, I think you have seen or heard enough of me. You want to see the real thing, and that's where Tim will join it. Tim, take over.
Thank you, Vasu. All right, so Vasu laid the foundation, and I'll show you what this means in system language. Okay, so where can we start? I would say we first start heading to our service data plane, which is in this example, or in Gardener's example, the Gardener cluster. And I want to do this via our wonderful dashboard. So the Gardener cluster is where we create workload for the system, where all the fleet management happens. It's basically the entry point for every one of us. It's for the operators, but also for our stakeholders or cluster owners. So especially for today, I prepared this very nice project, the Kubernetes. And I already prepared 2 clusters. But what I want to do first or next is we just create a new cluster. We create a new shoot cluster, and I'll explain to you what happens in the background. So I have this dialog, and I can randomly choose whatever is best for my use case. But for the purpose of this demo, I'll just click some random stuff. So I say I want to have a managed Kubernetes cluster, a shoot cluster on AWS. I give it a name. I pick some Kubernetes version I want to have. I can have to pick infrastructure credentials where all the infrastructure is created. I can pick my my tolerance if I want to have high availability. I'll come to that later a little bit. Pick some DNS configuration, and so on and so on. And for the data plane, I have some worker configurations saying, okay, I want to have this type of worker machines on this distribution, in this case, Kernel Linux. I can set I want to have at minimum 1 worker and at maximum, let's say, 10 workers, and then some mechanism in the background can go ahead and decide if the cluster needs to be scaled up or down, depending on the workload that runs on the cluster. Pick some zones, some maintenance time windows where Gardener automatically updates my OS images and Kubernetes, and some hibernation stuff that is mostly for development teams so that the entire cluster scales down at night, for example, to save some resources and money, of course. Okay, and now we can go ahead and create this cluster. And what now happens in the background is this cluster definition is created in the service data plane, in the Garden cluster, in a Kubernetes cluster. So it's all Kubernetes that you see here. Even though you see it in form of a dashboard, the background is a Kubernetes cluster and a Kubernetes object, actually, or a Kubernetes resource that we extended the API, or Gardener extends the API via an aggregated API server. And then different controllers take their work on. So for example, we have the Gardener scheduler that takes the shoot definition and picks a nice candidate, in this case, a seed, which is our hosting cluster, depending on, for example, the infrastructure provider we picked, the region we picked, and so on and so forth. So there is an algorithm, like also from Kubernetes, how to pick the best node. Something similar happens for Gardener here as well. Then that kubelet gardenlet in that seed kicks in and creates all the stuff that is necessary for that cluster. It creates the control plane on this hosting cluster on the seed. And it also takes care of creating the machines, the network, the data plane, or the management stuff that needs to be in the shoot cluster. I'll also show you that in a second. And all that stuff now happens in the background. And you have here, of course, this nice bubble or that nice identification how much the process already is done. So what is now interesting to notice is that I told you all of that in the background is more or less a Kubernetes cluster. I can demonstrate this to you nicely. So let's pick this one and connect to the Garden cluster. So this one is the terminal dashboard that is offered by the Garden dashboard. And we can now connect live to the Garden cluster, to our service data plane. And we can use the well-known Kubernetes tools to dive into the world of Gardener and Kubernetes. So that means if we get a kubectl, so K is an alias for kubectl, you should probably know that. And you see the shoot. So this one lists all the managed clusters, shoot clusters of my project here. And you see this newly created shoot is already shown here. If I look at it, then you will see a lot of stuff that can be configured for the shoot cluster. But interesting to notice is that you have a Kubernetes object. So this is what I meant. Gardener extends the Kubernetes API, and it purely uses Kubernetes architecture, but also Kubernetes techniques. Okay, so this one can be created in the background. I don't want to bother with that anymore for this demo, but let's pick one that we already created, and I'd like to show you a little bit how that cluster looks like and what we can do with this hosted control plane approach. So again, we use our terminal feature. We can connect into the control plane first. Again, this is a Kubernetes cluster. It's a different one in this case. It's the one that was picked by the scheduler yesterday when I created the shoot. And it's, in this case, some GCP hosted Kubernetes cluster. So, and what I can do here again is I can list all the pods, and this is actually what I see, or what corresponds to the control plane that is hosted on that seed cluster, on that Kubernetes cluster for this shoot cluster. And this should also look very familiar, especially the core components of a Kubernetes cluster. So for example, we have etcd for persistence. We have the Kube API server. We have the Kube controller manager, the Kube scheduler. We have some more stuff. We have stuff for auto scaling. We have deployments and stateful sets for logging and monitoring, CSI. So this is what Gardener plus extensions define as a control plane for this shoot cluster. On the other hand, I can connect to the shoot cluster. So now it's scheduling. Okay. And this is the view that a shoot owner would get. So here, for example, gets a kube config, configures the kube controller or whatever tool is responsible for that, and gets this cluster. And these are, for example, the elements that need to be placed in such a cluster. So for example, that are still managed by Gardener, but not hosted anymore in the control plane, but need to be on the nodes, especially as a daemon set, or also for core DNS as a deployment. I don't want to pick them out particularly, just want to show you the difference between the control plane and the so-called data plane. And to show you that we actually have really hardware behind this is, as you remember, I defined I want to have a minimum of 3 worker nodes. Here they are. But we don't have any real workload now on the cluster, and this is the reason why the cluster autoscaler just decided to start with the minimum. And as soon as we start to deploy real workload, depending on the resources they need, then of course the cluster will scale respectively. Okay, so this is shoot, seed, hosted control plane versus data plane. What can we do with that? So let's imagine we have a seed cluster, our hosted cluster, and that has outgrown for some reason. So maybe it hosts too many control planes. Okay, that can be one thing, but we can solve that problem by adding another seed, another hosted Kubernetes cluster, and put more control planes there. But there are other scenarios, like you have network configuration. You may decide to, or your infrastructure provider decided to add new regions which are now interesting to you, because you can place the hosted control planes closer to the data planes. So, okay, you can now go ahead and create that new seed, that new hosted control plane cluster in that region. But what do you do with the existing shoot clusters? Do you want to say, okay, it's now the situation that you have to create new shoot clusters. It's up to you, dear customer. No, we can do better. We can even move the control planes to that new particular seed cluster. And this is what I'd like to trigger in this demo. So let me start here. So maybe I can show you this. Okay, so at the moment I'm on seed GCP-H8, and I have another GCP seed in that landscape, and I'd like to, as I said, migrate to the seed cluster. Let the control plane being hosted there. So that's what I can do as an operator. So that's an operator feature actually. And I'll put that one on GCP Cilium. Another example, the one that yes, sorry, thanks. Okay. Okay, now this one is scheduled to the GCP Cilium seed. You also see this here. And now it's loading. So what happens now is it's migrating. And migration basically means it takes a full snapshot of the etcd persistent. So 1 second. So it decomposes the control plane on the left side, and it will reconstruct the control plane then on the right side. So this is when the restore happens. And after the restore finished, we have successfully moved the control plane to this new seed cluster, and the data plane is untouched actually. So if you don't have any critical workload that runs on the data plane that relies on 100% API availability of Kubernetes, then your workload will totally run fine and continue to run during this migration step. So no problem at all. Okay, so this can run in the background. I hope that I don't forget to switch back to show you that it actually worked. But I want to give you another example what we can do with this control plane hosting. So I have prepared another shoot cluster on AWS. And this time, let us look and concentrate on the nodes. Sorry, that was my fault. Let's go back to the GCP. I think the right one is. Okay, let's restart this. It's taking a while because the terminal controller needs to place the pod inside the cluster that needs to be scheduled and then building up the connection. But maybe I've run into a timeout. Okay, let me show you this really quickly in the dashboard. So what I defined for this shoot cluster is to have workers in 3 different regions. So what I wanted to show you in the terminal is that I actually have nodes in these 3 different regions. And the nice part about it is the result of this shoot cluster is a Kubernetes cluster. And what can we do with a Kubernetes cluster? Well, we can host control planes. So we can take the shoot cluster, register it as another seed cluster, and get all the benefits, all the settings, all the management features that we have for ordinary shoot clusters now for the own host seed clusters, which is a real benefit here. And one example is to have worker nodes in 3 different regions, in 3 different zones is I can define a failure tolerance for shoot clusters. This is what I did for this cluster. Let's hope that this works. And then we'll compare this control plane to the control plane that we just saw of the GCP one. Just give it 5 more seconds. Okay, here we go. Okay, so what do we see? We have more etcd replicas suddenly. We have more Kube API server replicas, and we have much more. So what we did is with the characteristic that our management or our hosting clusters has nodes spread across zones, we can instruct Kubernetes to place those replicas so across the zones. And this is what happens here. And thanks to that, we can define for the shoot being tolerant to 1 zone outage on our cloud provider. So this is another example where we use the Kubernetes mechanics and also the architecture to benefit from the entire control plane hosting. So let's look back. Okay, still happening. Okay, so this is one of few examples what we can do with this hosted control planes. Another example is extensions. Let's say, for example, we are a provider and we want to have well-known extensions. So stakeholders approach us or customers approach us asking for, why do I have to deploy Flux myself? I have a lot of Flux use cases. I know some neighboring teams, Team A, Team B, Team C, they all need to have Flux, and we all have to solve that challenge for ourselves, how that Flux deployment should look like. Isn't it possible to have a controller in your seed cluster that deploys all of that for me as I need it? And this is what actually can be done with the extension mechanism from Gardener. So one of our community members, 23 Technologies, and now maintained by Stackit Cloud, they took Flux and built a Gardener extension around it. So when this is registered, I can tell my chute that it should use a Flux extension. This means that a controller in the seed cluster goes ahead, it reconciles that specification and does whatever is necessary to offer a Flux service to the chute cluster. So if we go back, okay, now this one is, okay. Then we would have seen that in this particular chute cluster, there are some Flux pods running and just offered or deployed and managed by that controller in the seed cluster. Quite similar is the certificate service. So it's not only Flux, but also challenges like how do we get certificates for our services inside the cluster? How do we get DNS? And this is another great example. And something that you will see here is Yes, there it is. So this is another extension that was requested by the chute. Please give me a DNS service. And then the workload in my cluster just needs to annotate, for example, a service. It exposes, and the service in the control plane goes ahead and creates everything necessary for my service to be exposed. All right, so demo got, unfortunately, the migration couldn't finish yet, but that's it from my side. In case you have any questions, I'll be around till end of this event and happy to talk to you. Thank you.
Hello, are there any direct questions here? Yeah, okay. Hold on with the mic.
So I had this one question. The extension feature is quite a helpful feature. The only thing is there a planned support like admission controllers like Kyberno? Because we have certain requirements also to have compliance and stuff like that. So instead of a default tool set change in the cluster.
Kim, do you want to take it or?
So at least I'm not aware that we are going to develop a Kyberno extension from the Gardener org, but this is also like a give and take, right? So it's very open, that extension concept, and pretty simple to contribute such an extension. But I'm at least not aware of today that it's something on the roadmap.
So anyway, the thing is that when you host the Kubernetes control plane, right, on a seed or on a hosting Kubernetes cluster. The thing that we do is we create a namespace, and there all the pods run, right? But the thing is, you don't only need to do it for the Kubernetes control plane. You can actually do this for the Istio control plane, or like the Kyverno control plane. I don't even know. I think they also have some controllers, of course. Yeah. And you do this just like in the Flux example, which unfortunately, Democrats, you actually clicked, I think, on the wrong cluster to be migrated. Separating the control plane away from the work plane, from your nodes where the end user has direct access to, is actually a good thing. Right? You can actually use the hosting concept also for all types of other control planes. All right, with that, I'd say maybe at the end, we'll see it migrated, and 28% is the progress. With that, I hope the pizza is already there. If not, there's now time to network. Guys, say hello to your to the neighbor you actually don't know, right? Okay. See you back in 15, 20 minutes for the next talk.
It takes longer. We can
Sollen wir die Recording stoppen?
Ja,
Stoppen.
sehr gut.
Hi, John. Du hast, glaube ich, echt den falschen.
Hi. We have interacted a lot on Slack. You may not remember.